All right, welcome everyone. In part two of our lecture, we're going to be mainly focusing on getters and setters. Now, we are going to dive a little bit into the concept of privatizing information as well. And that's where getters and setters are really going to come in. So getters and setters are utilized to specify how someone can access an attribute. Utilize the setter to specify how someone can change the value of an attribute or if a value of an attribute could change at all. Now, what is a decorator? A decorator, in simplistic terms, is a function. And actually, we're going to come back to this. We're just going to save this part of the slide deck for later on. All right, so as of now, we have our dog, Shadow. And, once a dog gets a name, maybe there's something that we don't want to change about said dog. And we can dive into a couple of different examples here. The first one I'm going to be diving into is going to be color. Now, a getter is pretty simple. Go ahead and do this number here. Oh, looks like I have this Copilot thing back on. Gotta work on turning that off permanently whenever lecture's coming on. I apologize, everyone. All right, so a getter is utilized to grab a value from a class attribute. So this was pretty simple. We can say at property. This is saying this is a property that belongs to this class. And actually, before we start diving in here, I'm just going to make the getter itself. Let's say all I want to do is grab the color. Well, I'm going to do a color. It's going to take in self. And what it's going to do is it's going to return self.color. Now, if we're going to privatizing these things, as you can see, color is now the color yellow. Whereas before, it was kind of this light blue. Well, that's because it's not being recognized as an actual property. Well, what we can do to let other developers know that they're not supposed to interact with this attribute is add an underscore. Now, this doesn't actually privatize the value. And if you read into the Python documentation, some of them say that you could add double underscores. And by adding double underscores, it says, hey, this variable here is not supposed to be accessible. It's supposed to be something that doesn't get touched. Whether you do an underscore or double underscore, it's not really going to privatize it for you. You can still change the value inside of it. It's more of a syntactical concept to let other developers know that they shouldn't be touching it. As far as the actual Python program restricting you from touching it, that's not going to happen. Python doesn't have the capability to actually privatize a variable. Again, this is just a syntactical convention that we can utilize to tell other developers this is privatized, don't touch it. But in reality, this is still accessible and can be utilized throughout the program. All right. Well, now let's take a look at how this works here. All right. I'm going to actually make a different file here. I'm going to say touch runner.py just to have things a little bit cleaner. And I'm going to take our dogs over to the runner. Oh, I put that in the wrong location. That's going to go into 1, 2. All right, so there's my runner. And in this runner, I'm going to paste that information and I'm going to import that class. I'm going to say from main, I want to import dog. That way it's a little bit clean as far as the information that we're writing here. Okay, so here's my dog. I've added this color variable, and all it's supposed to do is return the color. Now, if I say my dog, or if I print my dog dot color, and I run this function, You can see that what it does is it tells me there is a method that's being activated. Well, that's because I'm not calling the method. And if I call the method, it's going to actually return it. Now the concept is there, all right? I'm able to write a method that would return this information, but this doesn't actually turn it into a getter or a setter. Now, preferably a getter would be something that I don't have to call as if it were a method. So in order to actually turn it into a getter, I have to add the at property. And by adding at property, well, now I can just call my dog duck color, and that will return the double underscore color. Right? I'm never actually, by doing this my dog dot color, I'm not actually grabbing the value of underscore underscore color. Instead, I'm grabbing it by reference. Right? I am returning the value of the self dot underscore underscore color without actually interacting with it. So that's a getter. Right? Now, when other developers need to utilize the color, they can do so by using this method here. That's what turns it into a getter. So let me go ahead and add that here. The at property syntax turns next method into a getter. Now notice that blank space doesn't affect it. I can put a bunch of blank space in there and everything still runs great. Once you declare the at property, it's just looking for the very next method, and that's how it will be implemented. And we'll talk about what these decorators are here shortly. All right, does anyone have any question over the implementation, or excuse me, questions over the implementation of a getter? Go ahead, Thomas.
So how would, since we haven't talked about setters yet, how would getters work within a class itself? Say you're trying to call the output of one of the class's functions within one of the other class's functions. Would it prevent things from happening if you privatize certain functions or not?
Got it. So when you're saying functions, I think you're talking about methods.
Yeah,
And
methods. I didn't know if to whether or not to refer to them as functions if I'm referring to them within the class itself, since it's still in the class, or methods, since I'm not outside of the class yet.
got it. Okay, so within the class, there are always going to be methods. There's class level methods and instance level methods. All of these are instance level, and we'll talk about that later on. I think the question that you're asking, it's going to be, I could try to answer it now, but it's going to confuse, it's going to be more confusing than anything without having a visual representation. So I'm going to go ahead and put that question on hold, and then I'll ensure to address it in, I believe, tomorrow's lecture. Tomorrow's lecture will actually be working with multiple classes. All right, fantastic. Okay, so as of now, I have this property. It's my getter. It's able to grab the self.color. But just like we mentioned, this still isn't privatized, right? What if I wanted to set a color? Well, a setter is going to be, subsetter is utilized for defining if and how devs can change the value of a color. And we do this by marking the name of property dot setter. So let's say we have a couple of requirements for the color. And just for simplicity's sake, let's say we call it set color. Well, let's have an acceptable colors list. Let's say we do brown, we do red. Actually, I guess red wouldn't be a thing. Maybe gold. black, gray, and white. I can't really think of any other colors, so I'm going to leave it there. All right, so there we have our acceptable colors list. And what we want to do is we want to make sure that if we set the color of a dog, it is within this array. So we'll say, hey, if, and here's where the argument comes in. I'm going to say the new color, or let's call it, yeah, let's call it new color. Let's say if new color is in acceptable colors, then self dot color is equal to the new color that's being passed in. Otherwise, I would probably want to raise an exception saying, hey, the color must be within, and let's turn this into an F string so that we could just plug in our list there and say acceptable colors. All right, so now we have a set color function here. Let's call my dog dot set color. And let's say that the color that I want to pass in there will be, let's try red, just so we can see that exception happening. Well, here's the exception that I rose, the one that I wrote down, right? An exception is being risen telling me, hey, there's a problem inside of your program. So if other developers try to change the value of a color, they're going to get an exception saying, I created this class. I specifically want this to be privatized, and only this convention should be acceptable. All right. So I am creating a rule set for what is acceptable. And I'm also being pretty informative to the developer in the exception, saying the color must be within brown, gold, black, gray, or white. Great. So now as another developer utilizing this program, I can see that there's an issue here. But again, this is just a method. This isn't a setter just yet. Well, the way we turn it into a setter, we utilize at. Again, it's looking for the name of the property. Well, the property that I declared was color. So I'll say at color dot setter. And that changes the way it works. Well, let's see how this syntax reacts now when I try to execute the script. Well, now when I try to execute the syntax, it's telling me that a string object is not callable. Okay. Well, this decorator that we're utilizing up here mutates the way that this method works. Instead of set color being a method now, it is a setter, meaning that I would call it with an equal sign. This red would still fall under the argument for new color and raise an exception. So now if I change that red to brown, and I think, what is shadow's color? Shadow is brown. So let me go ahead and change that to, let's go with gray. And I go to execute my script when I get brown and gray. My getter for being able to grab a color functions properly. It grabs the underscore underscore color. And my setter also works for being able to change the color. All right, awesome. Now I was able to create a getter and a setter, but let's clean up our syntax a little bit. Although this is a functional program, this doesn't really follow the Pythonic convention that we're looking for. This set underscore color shouldn't be a thing. It's actually supposed to be just color. You can see how that can get confusing because at this point we're referencing color in like 5 different spots, right? There's color here, color that's being passed in from the actual attribute. Then we have the color setter, and then we also have to call the setter color as well. So it can become confusing. That's the reason why we broke it up the way we did the first time. Now, if I execute my script one more time, you'll see that everything still works. It's able to identify the difference between the getter and the setter, because of this equal sign. When I run the equal sign, it knows that we're looking for the setter. And without the equal sign, when I'm calling it right up here in line 6 and line 7 and line 8, excuse me, it knows that since we're not utilizing an assignment, all it's doing is triggering the getter. All right. I know that's a pretty, although it sounds small, I know that's pretty confusing. So I'm going to go ahead and open it up for questions in case there's any confusion here. All right, go ahead, Arnold.
Just to clarify, so in getter or property, you could only return um one thing, basically the self, and you can't add another parameter from it.
So here it's only going to return one value. That is correct. Now, that one value can be multiple things if you want to, I don't know, put it into like a tuple and then say, hey, this is also color, right? By that way, you can return two things. But by default, the app property is only returning one, right? What it's returning here is a tuple. And if I take off that tuple, what it's returning is self dot underscore underscore color, right? So it only returns one value at a time. If you need to return multiple things, you would have to nest them within a parental data structure. Does that answer your question, Arnold?
Yeah, so just to clarify, so the app property, the getter, is basically establishing, so this is how we establish for our setter, the future coding, for the future lines that we want to change something.
Yes, that's correct. So by saying app property color, that's what allows me to do this color dot setter, right? So this grouping is what creates this first portion of color.
So does that mean, so let's say along the lines, like you decided to change the color, you have to go back all the way to the start to put the add property and then do the add color dot setter. If you did decide it like at the end,
Decide what?
decide to change it.
If you decide to change it by creating the setter, you can always have the way to change it. I don't think I'm understanding your question.
So let's say you're doing uh all your codes and then you came across like you decided to change the color. So does that mean you go back all the way to the start and then put in add property so that you can start the color dot setter?
Okay, so I write all of my code.
Mhm.
Are you referencing to the, for example, the blueprint, or are you referencing to the execution file?
The execution file.
Okay, so I'm writing all of my code here, and then I decide to change the color, like I do here in line 7.
Yes.
Yeah, so if I wanted to do this, there would have to be a setter already programmed within my blueprint. Otherwise, it wouldn't work.
Thank you.
Of course. All right, Angel.
Okay. Hopefully it's not dumb, but I know we learned like Dunder and all this other stuff a moment prior to the break. But the self dot underscore underscore color, what's the purpose again of the two underscores on color? Sorry if it's obvious.
No, no problem at all. So this underscore underscore, it doesn't serve anything to as far as like programmatically. It's strictly just to let other developers know that they're not supposed to interact with this property um directly. They're supposed to interact with it utilizing getters and setters. It's just a convention for other developers to be able to identify that. Does that answer your question, Angel?
Thank you very much.
Okay, perfect. Rick?
Yeah, I might. So yeah, so in your runner, you're getting the value for the dog, and then on your setter, you're setting it, and you're saying like in your class, you're not supposed to, yeah, only interact with color with setters and getters. Mm, Okay, I mean, my question may not make any sense then. All right, I guess my question is say in the class you go on and set the color in the class. Um, is there a way to make it immutable to where like once you set something, it can't be changed by a setter?
Yes, there is. We'll go into that here shortly.
Okay, I was just curious, if I ever had like uh, in this dog example, it doesn't really apply, but like if you had like another situation where you set something, um, then somebody coming in couldn't set a setter and change the value on you. And all right, okay, all right.
Awesome. All right, let me finish off this example and then we'll come back and see what that would look like when we want something to not be changeable at all. All right, so now I have my getter and setter. And we learned this convention here of the double underscores. But when I run this convention, when I run my initializer for the first time, it's not actually utilizing my setter property. As you can see, red is not an acceptable value for line 33, right? But if I come over to my constructor and I change this to red, and then I run my script, it's going to work. It's allowing an improper value to be set for the color of red. So there's got to be a way to fix this. And I'm kind of walking us through everything step by step and giving us little hints as to how we came to this convention. So we were able to define a getter, we're able to define a setter. But now, instead of working with color, underscore underscore color, we're just simply going to change this to utilize the setter. And we know it's utilizing the setter because it's looking for the assignment. So now, when I run my script, I'll get an exception saying the color must be within brown, gold, black, gray. So I could come back and I'll change this to brown. So now the only value that's being changed for self.color will always run through a getter or a setter. There's no other way to interact with this property with the exceptions of getters and setters. All right. Now let's talk about the privatization or the scenario that Rick just described to us where something can't be changed. Let's talk about name, for example. Well, I can say app property because I know that's what marks my getter. Pass in name. We know we're working with self. And all I'm going to return is self.name. Well, what about the getter? Or excuse me, the setter? What would that look like? First, I ask for the setter. I pass in the name, self, comma, new name. All right. Well, upon initialization, this self.name equals, it's going to assign for the first time. Meaning that prior to self.name doesn't exist. All right, so we're talking about the execution code or the way that code is being executed. Now we're working with timelines, which might be a little confusing. I'll do my best to break it down here in a drawing after we see it being executed in code. All right. So now what I can say is if has attributes, and this has attribute function checks for an object. The object that I'm checking is the class itself. And the name of the attribute that I'm looking for is name. If this object has the attribute of name, then I'm going to raise an exception saying name has already been assigned to And let's just do this whole F, turn it into an F string, and do self.name. And otherwise, I can say self.name is equal to new name. Well, let's try to run this. Let's make sure that everything works within my execution file. I'm gonna run the runner. Okay, I'm seeing a little bit of an error here. So let's see what's happening here. I'm getting a maximum recursion because I am calling self.name. And I'm passing in the new name. Make sure that works here. Oh, there you go. That's the issue. I apologize. Just like earlier, we're still interacting with underscore underscore color. Down below, we're still interacting with underscore underscore color. That recursion that I ran into is because it was trying to utilize the setter over and over again. So now it's going to set it to self underscore underscore name. And let me do that as well. Perfect. So now when I run this, I get brown and gray. If I go to print my dog.name, we're going to see shadow. And I'm just going to comment this lines out. If I try to set a new attribute, let's say I call it Apollo, and I try to execute this, see that it doesn't work. I did expect to see an exception being risen. Doesn't seem like that was triggered. So let me just make sure that this works here. Interesting. So this has attributes returning false, and it should be returning true. So I have to check why exactly that is failing. I don't want to open up that rabbit hole as of now. So we'll come back to this. We'll put a pin on this, come back to it, and clean it up at the end of our lecture. All right, but this would be how we would privatize our information. Again, we'll come back and revisit that. Now, the next thing that I want to dive into is going to be decorators. Everything that comes with an @ sign above a method is known as a decorator. But what are decorators? Although we're understanding that, hey, it's turning this into a name or it's turning it into a property, and this is making it available as a setter, why is it that the behavior of the following method is changing? Right? For example, this method, no longer is it called like a function, where I would say func call with attribute being passed in. Instead, it's being called as property equals attribute being passed in. But why is that? Or how is this behavior actually changing and happening? Let's talk a little bit about the background of Python as to what is a decorator. A decorator, and let me show it this way. We can create a function with instructions, otherwise known as a decorator. But what's unique about a decorator is that a decorator is a function that takes in a function. Kind of like a wrapper. These instructions could be things that happen before and after the function, or it could be things that just describe exactly how the nested function is supposed to execute. That's all we're looking for. A decorator is a function that takes in a function. Okay, well, I'm going to make my function, or I'm going to call it my decorator. Again, all a decorator is a function that takes in a function. And here I can define a wrapper. And all I need to return is the wrapper itself. Now, by returning the wrapper, notice that the wrapper isn't actually being executed or called in this return statement. The at my decorator, this will trigger the return function call, which in this case, what we're talking about is the wrapper. So for example, if my wrapper is just print hello, and let's say I do a function called add nums, takes in int or 1 and 2, and all it does is return their sum. I go to add nums, pass in 1, 2, and I execute this. Let's do Python decorators.py. Well, you can see that there's an error being risen. It's saying, hey, the wrapper takes 0 positional arguments, but 2 were passed. It's because I'm passing in 1 and 2. So let's go ahead and add that in there. 1, 2. And actually, I don't want to make this overly complicated. So let's go ahead and do this number. Just to keep things simple. Right, we run this, and we can see that it says hello. Well, I'm not printing the outcome of this add nums. Again, when I call this add nums method, or excuse me, function, it triggers the decorator. The decorator then triggers that wrapper call, and we can see print hello. Now there's other things that we can utilize here. For example, I can actually call the function that's being passed in. And then I can print after. Or let's do goodbye. Instead of this return, I'm going to do print. This is the function passed into the decorator. Well, now when I execute this, you can see the decorator gets passed in the function of add nums. So add nums now becomes func. The at sign triggers the decorator, which is wrapper. So it triggers the function. We can see the initial hello being printed. Then our function call happens. So this is the function being passed. That's what we see down here in our terminal. And then finally, once that function is completed, we can see some steps after, which is print goodbye. And that's the end of the execution. Right? If we see this in a roadmap, let me do. Let's do the function is called. And let's call it a fake call, right? It's called, but not really. It's called, not executed. There you go. That's the best way to do it. After that, the decorator triggers return function. The return function executes the original add nums. And then it closes the execution loop. Original function gets called. Decorator triggers the wrapper. The wrapper begins the execution loop. We see hello. We then actually execute the functions being passed in. We see print this is the function passed into the decorator. And then finally, goodbye. So that gives us a little bit of background as to how decorators are working. If we go back to main.py, here we can see the app property decorators being passed in. And what this does is it has some information in the background. Let me see if I can open it. All right, that doesn't really give me any useful information. So what this app property does is it changes the behavior of the function being passed in for name. Where now, instead of being called as a regular function with the open and closing parentheses, we can just describe the name and it knows what behavior to take upon. And same thing with the setter. We have changed the way this works so that it can follow a new convention that we ourselves describe. And instead of being triggered like a regular function, it's being triggered by assignment. All right, does anyone have any questions regarding decorators? It's definitely an advanced topic, so I wouldn't worry about memorizing exactly how decorators work. We're never going to expect you to write a decorator from scratch. That's a task that's a little bit more in depth than what we need. What I really just want everyone to have is a basic understanding of, okay, this isn't magic. There's actual things going on in the background that's changing this information. Go ahead, Rick.
Yeah, I was just gonna ask if this is like just a better way of doing nested functions, like a function inside a function inside a function. Is that what this does? The well, now I'm brain farting. The
Decorator.
yeah, the decorator, is that just like a prettier way or a more functional way of actually doing functions inside functions inside functions?
I would call it a prettier way, for lack of better words, right? It's things that need to be executed in a specific format, and then it's just dry principle. Do not repeat yourself. So now instead of having to rewrite it or change it or mutate it every time, it's already set to take in any sort of function that's being passed into it. All right, Ryan.
Yeah, this what was the purpose of the original example in the decorator having the num like 1 and 2 and then not having that actually print? I guess I
Uh,
just didn't really follow when it wasn't printed and what the purpose of just not printing it was.
yeah, absolutely. So the only reason why I'm showing this print is because I want it to be noticeable here that we're seeing it in the middle of this wrapper function. It doesn't really change the way that the wrapper is working. I could have it return numbers for sure. I could say, hey, return 2 plus 2. All right. And it would work exactly the same. We just wouldn't see it because we're calling the function, but not printing. I would have to just move the print method up above.
Okay,
And
gotcha. Thank you.
yeah, now you would see that for. Awesome. Angel?
Oh, we were just doing like the getters and setters a moment ago. and now we're doing the decoration, the decorator. Where does that fall in the four pillars, or is that outside the like where what part of that would be in the pillars?
This decorator is additional information. Doesn't fall within the OOP part of everything that we're learning. This is just so that we understand that in this main.py, when we're building our class, these decorators, this is how they work, right? They're essentially just taking in the function that we have under them and changing their behavior. But it's not something that we're going to have to implement or dissect at any point. Does that answer your question, Angel?
Yeah, that helps.
Awesome. All right. Now, I do want to fix this example for us. I don't believe we have any more material other than the roadmap. So let's go ahead and take a 4-minute break while I figure out this example, and then I'll bring everybody back in to clarify this example. That way you guys aren't watching me debug on live. All right. Thank you so much, everyone. And I'll see everyone back shortly. Okay, fantastic. So I'm going to go ahead and execute this here. So before, the mistake that I had was that I had underscore name, and it wasn't able to identify it. It looks like by placing the double underscore in the way that we want to identify it, we have to utilize the dir function to actually see all the attributes that are inside of this class. So all of the attributes inside of this class are being listed to me here down below. And you can see, where did you go now? All right. Let me run it here so that we can see it. Still doesn't show it. Nice. All right. So now you can see once the direction is assigned, or excuse me, once underscore name is assigned, there's this new property that shows up called underscore dog underscore name. And that's the part that I'm looking for. I want to make sure that that doesn't get reassigned, right? If I print this statement up above, remember, it's only running through the initialization method. There's no such thing as underscore dog underscore name. So this if statement would return false and actually set my new name. Whereas if I take this print statement down below, well, now you can see that the existence of underscore dog name is there because I set it on line 28. Excuse me. Well, now that I have that has attribute in place, I have my dog name. If I try to reassign it to Apollo later on, I'll get that exception saying the name. I put name, put dog. Dog name has already been assigned to Shadow.
Yeah, I was just with that question it can be taken care of at another level as well. I mean, I was just thinking like as in like a college setting or a school setting, you log in to website, Python's running in the background. As soon as the website fires off and you enter your name, then it creates a student ID for you, and all that is tied to databases. So you don't want the student to be able to change his own ID. And you could easily just, take care of that at the UI where, it's not a selectable value. But, with something like this could also be like a backup just in case it is tried to, it's somehow trying to be changed, then the code itself won't let it be changed.
Yeah, definitely. It's important to not only back up your user interface, but also back up all of your database servers or anything that's interacting with your database. We'll learn later on that there's a lot of protection built in already, but if you're working with something like Flask, you may have to implement some of these restrictions by hand rather than utilizing Django. All right. Well, let's talk about how this class came about and this example that we have up above here. All right. So let's say I want to start everything. I want to create a class. Well, the first thing I want to do is I want to outline my class. What I mean by outline my class is I would like to identify, and actually I'm going to write this more of a notes perspective here. Perfect. So I want to outline my class. I want to identify properties that I want to utilize. I also want to identify methods that my class should have. From there, the next step would be to identify properties that should be privatized through getters and setters. Now, this concept of getters and setters, although it's not very big in Python, it is very big in all other object-oriented programming languages like C, C#, Java. They all utilize getters and setters. So it's important for us to get practice with them, even if Python's not necessarily requiring it from us. All right. So now I have my outline of my class. I understand what my class needs. I can identify the properties that will be privatized through getters and setters. Well, the next thing I can do is declare my class. And by declaring my class, I mean utilize the class keyword. And I also want to utilize my init method or build my init method. That should always take in self first. Then, once I've declared my class, or I have all those things built out, I also want to work on getters, which we know come from the app property decorator. And I also want to work on my setters, which we know come from the the name of property, dot setter. Then finally, I just want to create an instance of my class. And I know I could do this by calling the class itself. And passing in all arguments, either by keyword or in positional order. And we've seen this in two ways now. If we grab positional order, let me actually just copy this straight from our runner. Here's our keyword method, and here's the positional order, where we can actually make an instance of the class. if we go into attaching every single one of these into the diagram up above, we can see it as such. Here is my class outline, where I'm identifying everything that needs to be privatized through getters and setters, the methods that I should have, and the properties. I typically like to draw it out, something kind of like a blueprint, just so that I have a visual representation of it. Then we have our process of initializing a class. Which falls under this init process once the class is being initialized. And then finally, we have the concept of making a class instance, which falls on the right-hand side. So that's how everything falls into place. We have our constructor, or excuse me, our initializer. Again, once you make something out of the class that is referenced to as an instance, and the class itself is just a declaration of the class, the blueprint. All right. So today we covered what is an object, what is object-oriented programming, and how object-oriented came about. We discussed the 5 pillars of OOP. We went over how to declare a class. We covered the init method and self. In part 2, we went over getters and setters, how to implement getters and setters, and we kind of talked a little bit about how is it that a decorator works in the background. Finally, we made a class roadmap together as a class so that we could visualize the process from start to finish. How do I create a class and then generate an instance of the class? At this point, does anyone have any questions over any of the material that was covered today? Let's hear it, Chris.
Yeah, going back to the decorator, I was just curious, does that at my decorator, does that allow you to go, I guess you would say, back in time? Uh, say you had attribute or I guess arguments within that function that weren't initially called, and they were, I guess, let's say they were set to, I don't know, false or null or something, and you know you're working down your line of code, and then now those I guess attributes are available. Does that allow you to go back in time and to re-execute, I guess, that function? Does that make
To
sense?
find them and re-execute it, you definitely can implement some sort of behavior like that, where it would be held inside of the scope of the decorator function. Um, There's other ways to go about it, because if you do it the way you're describing, there would be a lot of hidden code in the background, and as clean as it may look, it might be hard to follow along and understand how the program is being executed. But to answer your question, yes, you can implement something like that.
Okay.
All right, Arnold.
Going with that code, so are getters and setters only in class, or can you use it like outside of it?
That's a great question. I don't know the answer to that off the top of my head. I've only ever utilized the getters and setter concepts of app property and app property setter within the concept of OOP. So I'm not sure if it's only restricted to that. I'll have to look that up and get back to you with a good answer. I apologize, Arnold. All right. Any other questions? Awesome. I'll go ahead and stop the recording here.